Today's lesson is on logarithmic functions. Logarithmic functions are abbreviated as log functions, and logs are the inverse operation of exponential functions. So logs and exponents are inverses. Other inverses that we know of are addition and subtraction, also multiplication and division. Knowing that logs are inverses of exponentials, you need to be able to convert between the two forms. Right here you see log form, and right here you see exponential form. So before we start with the conversion process, there's a couple things you need to know about log form. Whenever you have a function in log form, your b value has to be greater than 0, and it can never equal 1. Also, your x value has to be greater than 0. Okay, so when you're converting between these two forms, there is a trick that I usually use, which involves drawing a circle around the function, and I'll show you that in just a second. That might help you and it might not, so it's up to you if you use the trick method that I'm gonna go over. Ultimately, what you need to do is memorize what's going on here. So if you have a logarithm with a base of b, in exponential form, that base is going to be the base of your exponent. Within your log, you have log base b of x. That's how you say that. When you convert to exponential form, your solution will be x. And lastly, your solution when you're in log form, your solution of y will always become the exponent in exponential form. So if the next method that I'm going over does not help you, what you can do is just memorize the location of all your parts and be able to convert between the two. So what I usually do is I write out my function. For example, log base 3 of 27 is equal to y. And I draw a circle starting at the base right around the function. So the base would be the first location, your answer is the second location, right here is the third location. If I was to convert this to exponential form, I would write the 3 first because that came first over here. Next, the next part of my exponential form is the exponent. Second is the value of y. That's going to be my, exponent. And the last part is the last thing you draw your circle around, which is 27. That's your answer. So it's just about placement. First, we have the value of 3, then the value of y, then the value of 27. In that order, you can write your exponential form. If I was to do another one, just really quick, and then we do have some examples to go through, but if I was to give you log base 2 of, let's see, what could I do for a real example? Log base 2 of 8 is equal to 3, and I draw this circle right around here. The first location that I drew or started drawing my circle from is 2. Then I draw by 3, and my last part is 8. And you can just check this, so see if this is true. Is 2 cubed equal to 8? And you hopefully all say, yes, it is, so that is correct. So you should know that this works either way. We just spent a moment going from log to exponential, but it also works going from exponential to log form. So for example, If I gave you, let's actually do the same two problems. So if I gave you 3 to the power of y is equal to 27, of course, it's a different format, but if you still start in the same order and draw your circle, you're starting at 3, you're drawing by 27, you're ending at y. If I was to convert this to log form, I should use a different color here. If I was to convert this to log form, I know I start with log, and then I start with start number-wise, I start with a base of 3, and then 27, so 3 of 27, and your last part is y, equals y. And if you compare that to where you started with, we have this as our answer. Right here was where we started. We converted, back and forth a couple of times, but we ended up with the same log function. So again, either use this shortcut / trick method or just memorize the order. If we look at this one, we know we have 2 raised to the power of 3 is equal to 8. We're going to draw a circle. Starting with log, we have log base 2 of 8 is equal to 3. And compared to where we started, yes, we have 2 of the same functions, so that is correct. Next, I'm going to go through the on your own section. I'm not going to talk through these. I think they're very repetitive. So if you just follow along, you'll see the answers. Hopefully you're all set with the conversion after these 6 examples. Evaluating log expressions. To find the exact value of a logarithm, write the logarithm in exponential notation and use the property of equality. Okay, so the exponential property equality is something we've already done this year, and it says that if you have b raised to the power of x, and you know it's equal to b raised to the power of y, then you know that x is equal to y, which are your exponents. And that only works because we have the same base, and by the base, we're talking about the value of b. If we look at a real example, 3 to the power of y is equal to 3 to the power of 5. Because we have 2 of the same bases, which is the value of 3, we know that we can set our exponents equal to one another. And in this case, you would know that your exponents, or y equals 5, would be the solution. We're going to evaluate these next couple without using a calculator. When you're evaluating logs, like I mentioned before, or in the box above, you need to convert to exponential form and then use the exponential property of equality. We have log base 8 of 16. This is equal to something, we just didn't write that at this point. So I'm going to rewrite log base 8 of 16, and I'm going to set this equal to x. That's just like saying, for example, 2 plus 2. If I read that to you, you guys would all say the answer is 4. But if I wrote 2 plus 2 equals x, you would say, okay, well now x equals 4. So it's the same idea. We didn't write an equal sign, but we're looking for the solution. So we'll add in this value, or we'll write in this value of x. The first step is to convert to exponential form. When we convert to exponential form, we have 8 raised to the power of x is equal to 16. When you convert to exponential form, you're going to have to create common bases. And the bases are the base of the exponent. So we need to rewrite 8 and 16. There's no other way for me to say this other than you just have to experiment with a number and figure out how you could break it down to the same base. So if you're good at your exponents, or you know what squared values are, cubed values are, fourth values are, then you should be pretty quick at doing this. If you don't know them, you're, again, just going to have to experiment with this. If I'm creating the same base, I know that both 8 and 16 can be rewritten with a base of 2. What I mean is 8 is 2 cubed. I'm going to write that in parentheses, and that is to the power of x. 16 is the same thing as 2 to the 4th. So I'm talking about the same base. I just created the same base. You need to know these values. You might need to make a list on the side of your paper. You might have to just sit there with your calculator and figure out how to convert them to a common base. But a base raised to an exponent has to equal what you originally start with. Once you create to a common base, you need to simplify your exponents, if possible. When you have a power to a power, you can multiply them together. I'm going to rewrite the left side of my equal sign as 2 raised to the power of 3x is equal to 2 raised to the power of 4. Once you have the exact same base with one single simplified exponent, you can set your exponents equal. We now know that 3x is equal to 4, or we know that x is equal to 4 over 3. Now, before I say this is my final answer, I just want to point out that you were originally solving for a logarithm up here. So originally we were asked to evaluate that log base 8 of 16. We did convert it to exponential form, and we solved that x is equal to 4 over 3. But I'd like to point out that you're solving for the log, so you should be writing your final answer in log form. That means we know that log base 8 of 16 is equal to 4 over 3. We solved for 4 over 3. We know that's equal to x. X is what our logarithm equals. So you can write this in log form, and you should be writing it in log form. So our final answer is log base 8 of 16 is equal to 4 over 3. Before I start number 2, let's just quickly refresh our minds on negative exponents. So if you have a to the power of negative n, you can rewrite that as a positive exponent in the denominator. But coincidentally, if you have a negative exponent in the denominator, you can rewrite it as a positive exponent in the numerator. So you might have to work backwards on those, but this is definitely going to come in handy or helpful on problems like number 2. I'm going to take log base 3 of 27, 1 over 27, and I'm going to set this equal to x. Following the same steps as before, I need to convert this to exponential form, leading me to 3 to the power of x is equal to 1 over 27. Well, if we work backwards from the negative exponent rule, If 27 has a positive value of 1 in the denominator, we could rewrite it in the numerator with a negative value of 1. I'm going to rewrite this as 3 to the power of x is equal to 27 to the power of negative 1. Again, that is just the opposite of your negative exponent rule. It's working backwards. You might have to take a second and think about that. In the denominator, 27 does have a power of 1. We don't technically write it. It is positive, so if we move it to the numerator, it becomes negative. Now that we got to this point, we can convert to common bases. We cannot break 3 to the power of x down any further, but we can break down 27. This equals 3 cubed raised to the power of negative 1. We can simplify any exponents, and if you have a power of a power, you multiply them together. 3 to the power of x is equal to 3 raised to the power of negative 3. Because we have the same base, we can set our exponents equal. Our exponents, or our exponent, tells us that x is equal to negative 3. Of course, our original problem was a logarithm. I'm going to write my final answer as log base 3 of 1 over 27 is equal to negative 3. Okay, follow along as I complete the on your own section. Next, we're going to talk about the common logarithm and the natural logarithm. So the common log is a log with base 10, and we typically don't write it. So anytime the base of a logarithm is not written, like this one here, it is assumed to be a base of 10. If you had to convert from log to exponential form or vice versa, in a problem like this, you would have to recognize that the base is 10 in order to accurately convert between the two. Also, if you start with an exponential form and you have a base of 10, then when you finally write your answer in log form, you don't necessarily have to write the base of 10. You can just write it like this. So common logs can be evaluated using basic properties or using the log key in your calculator. It's actually the only log that you can evaluate in your calculator. So log base 10 is in the calculator. Okay, the key specifically says log, and that's it. All right, so we also need to look at natural logs. And natural logs is a logarithm with base e, or the number e. So anytime the base of a logarithm is the number e, we use a special symbol called ln. So instead of writing log base e of x, we replace it with ln of x. And ln is also in your calculator. It looks like a button that says ln. If you had to convert from log to exponential form, you would recognize that ln of x is actually log base e of x, which would then allow you to convert to exponential form. All right, properties of logarithms. We're going to go over 4 of them. There are more than this, but on today's notes, we're just going to look at these basic 4 properties. So the first property says that log base b of 1 is equal to 0. That's for any base. An example could be log base 4 of 1 equals 0. And we can check that because if we convert to exponential form, we have 4 to the power of 0. Anything to the power of 0 is 1. Okay, so if you just see a function and it's a log, a base, and then a value of 1, you instantly know that the answer will be 0. If you have a log, this is number 2, a log base b of b, that means your base and your argument are the same, then the answer is going to be 1. If we look at an example of this, if we had log base 6 of 6, we know that if we convert this to exponential form and we solve, it's going to be equal to 1. And if you check this out, 6 raised to the power of 1 is equal to 6 is true. So I'm going over these properties, but they are just common sense, I think. If you were to try to solve them, hopefully you could figure out the answer. For the third property, this is an exponential form. If you have an exponential base of b raised to the power of log base b of x, so your exponential base is the same as your log base, then your answer is just going to be x, whatever that value is. 3 raised to the power of log base 3 of 2. Because we have the base of the exponent and the base of the log the same, we know that the answer is going to be this number here. So this answer is equal to 2. And lastly, the fourth one we're going over today says that if you have a log base b of b, so 2 values that are the same, and then you have an exponent of x, then your exponent is going to be your answer. For example, log base 4 of 4 squared is equal to 2. We know that the exponent is our answer. These 4 properties happen frequently, so just keep an eye out for them. Of course, if you forget them and you just go ahead and solve like you would usually solve, you're going to end up at the same answer anyways. It is helpful to know them as it is a shortcut for many of the problems. For example, if we look at number 1, right here we have log as an exponent. The full function is 3 raised to the power of log base 3 of 1. Well, this is property 3. Right here matches this one. So we instantly know that the answer is 1 without having to do anything for solving. I'll write a note off to the side. Property 3. And because the base of the exponent and the base of the log are the same, your answer is that number. So in this case, our answer is 1. I didn't have to solve anything there. I just know what the answer is. Number 2, because we have the base of the base of the logarithm, and right here, this is called the argument. So the base of the logarithm and the argument are exactly the same. That falls into the category for property 4. So I automatically know my answer is just the exponent. I don't need to solve anything here. My answer is going to be negative square root of 2. And I'll make a note for you that this is property 4. Number 3, we don't see a base to that logarithm, so I can rewrite it as log base 10 of 10. This is the common log. And if we compare to our properties above, right here, property number 2, if the base and the argument are the same, every time your answer is going to be 1. And lastly, we have number 4, which is ln of e. Anytime you have ln, you can rewrite ln, I'm going to just zoom out, right up here, the natural log. The value of ln is the same thing as log base e. So I can rewrite this term as log base e of e raised to the power of kt. Now we have a function that has the base and the argument both as the same number. That falls under category 4. So for property 4, we know the answer is just going to be your exponent of kt. The answer is equal to kt, or just your exponent. And again, that was property number 4. Okay, for the next section, you're doing these on your own. So this is just evaluating expressions. This falls into any of the categories as far as evaluating just the basic common log. So using your calculator for the common logarithm, using your calculator for the natural logarithm, or doing any of these 4 properties. So I'm actually going to leave these for you to do. I'll put my answer is on my website under the note sheet, so you can check it out there. But before I sign off of this video, I just want to point out a couple of different ones that you're going to have to do. So number 1 is going to be a property, just to give you an idea. So property. Number 2, you're going to have to use a calculator. You're going to have to evaluate this in a calculator. Number 3 uses a property to solve for. Number 4, you need to convert to exponential form and solve. So this is just like the first example set. Same thing for number 5, so convert to exponential form and solve for number 5. For number 6, we're going to look at a property for number 6, so evaluate that using property 1 through 4. Number 7 looks like something you're going to have to convert to exponential form again. And number 8 is the common logarithm, so for number 8, you're just going to have to evaluate using your calculator. Okay, so again, you have some using the common log, some using the natural log, some converting to exponential form and solving, and some of them just using one of these 4 basic properties. Okay, the answer key for this section is posted under the note sheet on my website, and I'll be going over more of them at the end of class.